Hi, everyone. Let's talk about determinants today. So I'm going to give you my screen. And this is going to be section 7.3. Introduction to Determinants. Now, a determinant is likely a new word for most of you. So I want to take just a minute. Sorry, let me get rid of that. And explain to you what a determinant is. So what we're doing from this point on in this chapter and in this course is we're working with matrices. Now, matrices are just a way to organize information. For example, 1, 2, 3, 4. If I put it in big brackets, that's a matrix. Matrices can come in almost any shape. We're going to work with mostly square, and we'll talk about those as we go, or augmented, and we'll talk about that too. But one of the properties of a matrix is the thing called its determinant. And we write that, instead of using the brackets, we use big, giant, absolute value signs. So this is the determinant of the matrix 1, 3, 2, 4. Okay. Now, let's talk about how we take a determinant. And essentially what we do is we take diagonal products. So I'm going to multiply down that diagonal. And up the other diagonal. Here's the only kicker. This guy is positive and this one is negative. So I put a minus sign in the middle. So the determinant of this matrix is 1 times 4 minus 2 times 3, or 4 minus 6, which is negative 2. Now, in the next section of this textbook, we will use determinants to find the solutions of systems of equations. So up until this point in this chapter, you've been doing solutions or finding solutions of systems of equations just exactly the same way as we did in Math 70. With the introduction of determinants, we're going to give you another tool to put in your toolbox. So let's do another example here. Let's take the determinant of the matrix 3, 5, negative 2, 7. Now we're just going to do cross products. So we're going to multiply down the left-hand diagonal, so from left to right, and that multiplication gets a positive sign. And then we subtract the upwards diagonal. Which will make it 21 minus a negative 10, or 31. All right. 2 by 2s are simple. So a 2 by 2 matrix is one that just has 2 rows and 2 columns. A, B, C, D. The determinant of a 2 by 2 matrix is just the number in the A spot multiplied by the number in the D spot minus the number in the B spot multiplied by the number in the C spot. That's what we've been doing. Okay. All right. However, as we know, not all systems are two systems of 2 and 2, right? So a 2 by 2 matrix would be what we would end up with if we were solving a system of 2 equations and 2 unknowns. Many of our systems are 3 by 3, especially the most interesting ones. So let's talk about what we do with a 3 by 3. And I'm going to tell you that the generalized definition of this is on page 510. So we're going to talk about 3 by 3 determinants. We aren't going to go any higher than 3 by 3. And I'm not going to write out the generalized ABC version that's in your textbook because it's hard to read. Instead, I'm just going to demonstrate how we find these determinants. So let's take a 3 by 3 matrix. And we're going to find the determinant of this matrix. 1, 3, -2, 2, 0, 1, 4, -1, 1. Okay, here's what we're going to do. We're going to take the first 2 columns and we copy them over. 1, 2, 4, and 3, 0, -1. Now we're still going to take our diagonal matrix, diagonal products. Let me get my green pen. Uh-oh. I let my green pen dry up. We'll have to make do with my red one and my black one. All right. So what we're going to do is we're going to take this, all the downward diagonal products. And the downward diagonal products all get plus signs. So our first term in our determinant is 1 times 0 times 1 plus 3 times 1 times 4 plus -2 times 2 times -1. Now we're going to take the upwards diagonal product. So start in the lower left and go up the diagonal. And all of our upwards diagonal products get negative signs. So now minus 4 times 0 times 2 minus -1 times 1 times 1 minus 1 times 2 times 3. Okay? Do our multiplication. 1 times 0 times 1 is 0, plus 3 times 1 times 4 is 12, plus -2 times 2 is -4, times -1 is 4, minus 4 times 0 times 2 is 0, minus -1 times 1 times 1 is -1, minus 1 times 2 times 3 is 6. So minus a -1 is like plus a +1. So that's 12 plus 4 is 16, plus 1 is 17, minus 6 is 11. Okay? All right. So practice that and make sure it's comfortable for you. This is one way of handling 3 by 3 determinants. It's my favorite way. I'm going to tell you straight up, this is the method that I use when I need to find a 3 by 3 determinant. I'm also going to tell you that I'm not going to hold you to which method you use to find a determinant. I just want you to be able to find them. I have no preference whatsoever how you find determinants. But your book does present a second method that I'm going to talk about, and it's called expansion by minors. And here's how this works. And as I said, I'm not going to hold you to which method you use to find a 3 by 3 determinant. I don't have a preference. I want you to use whatever method works for you. I just want you to be able to find the determinant. But I'm going to explain this to you because it's in your book, and it can be confusing. So let's take a 3 by 3 determinant. And again, I'm not going to do the ABC version because that gets really confusing. We're going to use numbers. And we're going to use 1, 3, -2, and 2, 0, 1, and 4, -1, 1. Now the other thing we have to do when we find determinants using expansion by minors is we have to talk about a sign array. And the sign array always looks the same. It starts in the upper left with a positive sign, and then we just alternate across the same numbers of rows and columns as we have in our matrix. So positive, negative, positive, and then we alternate down as well. So the next value in column 1 would be negative, positive, negative, and then positive, negative, positive. And here's what we do. We choose one row or one column to expand about. It doesn't matter which one we use, which row or which column. But whatever we do, whichever one we choose, we need to circle it. So I am going to expand about row. We'll use column 2. Your textbook uses column 1. So I'm going to expand about this column. So now I'm going to start at the top, and I'm going to write down the number. So this 3. And then I go to my sign array, and I pick the sign that is in the same location as that number. It's a negative sign. Now I mentally cross out both this row, because I'm working in the top row, and the column I'm expanding about. And what I'm left with is the matrix 2, 4, 1, 1. And then I do the same thing with the next element in the row or column I'm expanding about. So in this case, it's going to be a 0, and it's going to be positive. So plus 0 times. Now if I put back my 1 and my -2 and cross out lightly my 2 and my 0, I'm left with 1, 4, -2, 1. And then I've got a -1, but it's going to be subtracted. And if I put back what I had crossed out a minute ago, but now cross out the column that contains the element I'm working with, I've got 1, 2, -2, 1. Okay, now here's what I'm going to do. I'm going to find these determinants. So I've got -3 times the determinant of this 2 by 2 matrix is 2 times 1 minus 4 times 1 plus 0 times 1 times 1 minus 4 times negative 2 minus a negative 1 is going to be plus 1 times 1 times 1 minus 2 times negative 2. And 0 times anything is just 0. So we don't need to worry about that middle term at all. So we've got negative 3 times 2 minus 4 plus 1 times 1 plus 4. So negative 3 times 2 minus negative 4 is negative 2, plus 1 times 1 plus 4 is 5. Negative 3 times negative 2 is 6, plus 5 is 11. Now this is the exact same matrix that I worked a minute ago, right? And I found its determinant using the first method I showed you. And what did I get? I got a determinant of 11. When I expand it by minors, I also get a determinant of 11. And if you look in the textbook, you'll notice that even though they expanded about the first row, so where I used 3, 0, 1, they used 1, 3, negative 2, they also will get a determinant of 11. As I said, any way you choose to evaluate a determinant is fine. Your calculator can also help you find determinants, and this will be something I actually encourage you to master. It is kind of convoluted, so follow along and pause this as you go if you need to. The instructions are also on, so the steps I'm going to be following here can be found on page 513. Okay, I'm going to demonstrate this on a TI 84 because it's what I have. Actually, let me open up my digital version. I think that'll be better. Okay. So we're going to use this same matrix. I'm going to use the calculator to find the determinant of the matrix. So I'm going to find the determinant 1, 3, negative 2, 2, 0, 1, and 4, negative 1, 1. So a lot of steps here. This is something you're probably going to have to practice a few times in order for it to make sense. So what we're going to do is we're going to go into the matrix menu. Now the matrix menu is right here above the x to the negative 1. It's going to spell out the word matrix in the same color as your second key. Okay. Now we're going to select matrix A, which really just means you want to make sure this black box is right here next to the A. And then use your arrow keys and arrow over to edit. Hit enter. The calculator wants to know what size matrix you're going to use. We're working with a 3 by 3. Now just arrow down to go into the matrix and enter in all your numbers. So my first row is 1, 3, negative 2. Second row is 2, 0, 1. And the third row is 4, negative 1, 1. All right, your screen should now look like mine. And now what we're going to do is we're going to exit out of here. So we're going to quit. We're going to go second, quit. Matrix is still there. We're going to go back into the matrix. And if you want to make sure it's there, you can check it by hitting enter to get it on the screen and then enter again. And this is matrix A. All right, so let's go back into matrices. This time we're going to do a little math on matrix A. So I arrowed over to math. And what we're going to do is we're going to take the determinant. The rest of these things are other mathematical operations you can do with matrices. We aren't going to worry about them in this course. All we're going to do is take determinants. So make sure your little black box is on choice number 1 and hit enter. And now it just says determinant. What we have to do is we have to go back into the matrices and choose which matrix we wanted to take the determinant of. Hit enter, and it spits out 11. Like I said, there's some steps there. You'll want to practice them to make sure that you master them. If you're not working on a TI, I'm sure most scientific calculators can do this operation with matrices, and you'll just need to use Google to figure it out. All right. That's all I have for this video. Everybody have a great day wherever and whenever you are, and I will talk to you again soon.